Have you ever been so sure about something, so absolutely convinced, that the idea of you being wrong just seems impossible? Well, for thousands of years, all of humanity was sure about one really big thing, that our Earth was the fixed, unmoving center of everything. But what happens when one person with a revolutionary new tool looks up at the sky and proves that everything we thought we knew was wrong? This is the story of Galileo and how he totally changed our place in the universe. I mean, think about it. For nearly 2 millennia, the model of the universe was completely settled. It wasn't just science, it was common sense, it was philosophy, it was faith. We were special, we were at the center. And this was the picture people had in their minds, the geocentric model. Everything, the sun, the moon, the planets, all the stars, it all revolved around us, in these perfect, heavenly spheres. This wasn't just some scientific theory, it was the bedrock of reality. It was woven into culture, philosophy, religion. It literally pleased humanity right at the heart of creation. And then, along came a man named Galileo Galilei. The tool he perfected, the telescope, it wouldn't just shatter this old reality, it would give humanity a completely new way to find the truth. Okay, so to really get just how radical Galileo's ideas were, we have to first understand the world he was born into. This was a world where science was pretty much governed by ancient authority, not by new experiments. For almost 2,000 years, the ideas of the ancient Greek philosopher Aristotle were basically scientific law. He argued that the earth was motionless and that the heavens were perfect and unchanging. These weren't ideas you were supposed to question, they were truths you accepted. And, importantly, they had the powerful backing of the Catholic Church. But there was this other idea kind of lurking in the background. About a century before Galileo, an astronomer named Nicolaus Copernicus had proposed something truly radical. What if the sun was at the center and the Earth was just another planet moving around it? At the time, most people just ignored it. It was seen as a weird mathematical theory. But it was also a dangerous idea because if you move the Earth from the center, you're challenging humanity's special place in the entire universe. And this is where everything changes. For a long time, the debate between these two world systems was mostly philosophical, just a bunch of ideas. That is, until Galileo introduced a brand new, game-changing tool. Now, here's a really interesting detail. Galileo didn't actually invent the telescope. He heard about this thing called a spyglass from the Netherlands, and through his own skill and experiments, he quickly figured out how to build his own, far more powerful versions. And then, he did something nobody had really done before. He pointed it at the night sky. And what he saw was, well, it was staggering. The old belief said the heavens were perfect, but Galileo looked up and saw that the moon wasn't some smooth, perfect sphere. It was covered in mountains and craters, just like Earth. He saw that the sun, this supposedly flawless orb, had dark spots, sunspots, that moved across its surface, proving it was rotating. Every single observation was another crack in the foundation of that old, comfortable universe. But the real bombshell, the absolute game changer, it was his discovery of moons orbiting Jupiter. You see, critics of the sun-centered model always had this one big question. If the Earth is moving through space, why doesn't it leave its moon behind? But here was Jupiter, clearly moving, and it was holding on to 4 moons just fine. It was like a mini solar system, and it proved, without a doubt, that the Earth was not the center of all motion. And see, that was the whole point. Each of these discoveries wasn't just a fun fact. It was a piece of hard evidence. The phases of Venus, the moons of Jupiter, they all built this powerful case, based on direct observation, for the Copernican system. The proof was literally right there in the sky for anyone with a telescope to see for themselves. But Galileo's revolution wasn't just about the stars. He also turned his attention right back here to Earth, to the physics of our own world. And in doing so, he challenged another one of Aristotle's core beliefs. Not about the heavens, but about something as simple as how things fall. For ages, Aristotle had stated that heavier things fall faster. I mean, it kind of feels like common sense, right? A bowling ball should fall faster than a baseball. But Galileo didn't just rely on common sense, he relied on experiments. And what he discovered was that if you can account for air resistance, a heavy object and a light one will actually hit the ground at the very same time. Now, you've probably heard that famous story about him dropping cannonballs from the Leaning Tower of Pisa. It's a great story, but it's probably just that, a legend. Most of his real work was done with balls rolling down ramps because it was easier to measure. But that legend sticks around because it perfectly captures the heart of Galileo's new approach. Don't just trust what some ancient book says. Test it for yourself. So, as you can probably imagine, when you go around publishing evidence that overturns 2,000 years of scientific and religious thought, well, that doesn't exactly happen without some consequences. Galileo's discoveries put him on a direct collision course with the most powerful institution of his time. The timeline of what we now call the Galileo affair is pretty dramatic. His first big discoveries in 1610 made him famous, but they also started attracting some unwanted attention. By 1616, the church officially warned him to stop teaching the Copernican model as if it were a fact. For years, he kind of laid low. But then, in 1632, he published his masterpiece, a book that brilliantly defended the sun-centered system. The response from the church was swift. He was dragged to Rome, tried for heresy, and ultimately forced to recant. And this is so important. They could silence the man. They placed him under house arrest for the rest of his life. But they couldn't erase the evidence. The mountains on the moon were still there. Jupiter's moons kept right on orbiting. The truth, once it's out there, can't be undiscovered. And that brings us to his greatest, most enduring legacy. Because while Galileo discovered some absolutely incredible things, it's how he discovered them that truly changed the world forever. This is it. This is the big one. More than the moons of Jupiter, more than the mountains on our moon, Galileo gave us a new method for finding the truth, a process for figuring out what we think is true versus what we can actually prove is true. And this is it, the foundation of all modern science. He showed us that you have to observe carefully, and often with tools that can help you see more. Then you have to form an idea you can actually test. Then you have to experiment relentlessly. And maybe the most important part, your conclusions have to follow the evidence, no matter where it leads, and no matter what authorities tell you to believe. So when you add it all up, his influence is just immense. We call him the father of observational astronomy for using the telescope. We call him the father of the scientific method for his focus on experiments. And his groundbreaking work on motion and how things fall, well, that laid the essential groundwork for Isaac Newton to come along later and figure out the laws of gravity. In the end, Galileo's story is really about the power of looking for yourself. He chose to believe the evidence of his own eyes over the traditions of centuries. It was a choice that ended up costing him his freedom, but it was a choice that gave humanity the universe. His legacy is this incredible reminder that the engine of all discovery, of all progress, really just comes down to a single, powerful question. True progress doesn't come from proving what we already believe. It comes from having the courage to ask, what if we're wrong?